6. Cube and cube root. 7. Comparing quantities. 8. Algebraic expression and identities. 9. Mensuration. 10. Exponential power. 11. Direct and inverse proportion. Factorization and introduction to graph. Okay. Clear? Okay, just give me 1 minute. Somebody joined, so I just need to ask. Okay, who joined through the device? Xiaomi.
Ibrahim,
I can hear you, but can you rename yourself?
yeah, I'm joining from another device.
Okay, okay.
Excuse me?
Yes.
Can you give the option to rename?
Okay, tell me your name, I'll rename.
Oh, Ibrahim Jamal. Okay,
Sorry?
Ibrahim Jamal. Ibrahim Jamal.
Ibrahim. Okay, I'll just wait. Okay, Ibrahim, is it fine now? Okay, I think Ibrahim, this is also your very first class with me, right?
Second class.
Second class, you already have an introduction?
Introduction class.
Sorry?
Yes. Yes.
Okay, we already have an introduction. Okay. So what we did in the introduction class, you tell me something so at least I can get an idea.
The first chapter,
Hmm.
the properties of the property under multiplication, addition, and subtraction. We wrote notes about that.
Okay, we wrote notes about it. Okay, so I think after that you are joining a little bit like after few classes, right?
Yeah.
Okay. So today will be some like in the starting few minutes it will be a revision class for you. Okay. So that you can, because others will be making the notes, but you will be revising it. Fine?
Okay. Yes.
Okay, students. So we will be just starting with the chapter number 1, rational numbers. Okay. So I just forgot to ask Manal, what you are doing in your school, like which chapter is going on?
In my school, the chapter quadrilaterals.
Okay, third chapter is going on, right?
Yes.
Okay, so that means you need to work. You need to be very straight, because already we will be starting with chapter number 1, and you have to cope up that. Okay, so don't worry. We'll just try to finish as early as we can. Okay. Now, student, let's just start with a fresh mind. Everything fresh. Okay, fresh class, fresh chapter, everything fresh. Okay. First is rational numbers, right? So, ma'am, what are rational numbers, right? So, rational numbers are those numbers that can be represented in P upon Q form, like in the fraction form. Okay. But, like for example, 2 by 3, 3 by 2, 6 by 7, they all are rational numbers because they are represented in P upon Q form. Okay. But if I write this 3 by 0, is this a rational number, Ibrahim? 3 upon 0, is this a rational number? Tell me.
No, ma'am.
No. Why? Because over here, this denominator can never be equals to 0. Right? I already taught this, right? Taught this means those students who were with me in my previous previous classes like in 7th class. Okay. So remember one thing. If I'll ask you what are rational numbers, you will say, ma'am, rational numbers are those numbers that can be represented or that can be written in P upon Q form. But there is one condition that Q should never be equals to 0. That means the denominator can never be equals to 0. Fine? Yes? Everybody?
Yes, ma'am.
Vega, Abdullah, Ibrahim, Manan,
Yes,
Manal.
Yes,
See, so now one by one, everyone will tell me the definition of rational.
And if you put it like any number by 0, that means like it's the number itself. So there's no point in putting it like that.
Yes, so it's a condition. See, rational numbers are written in P upon Q form always. Right? But if in denominator you write 0, this is not a rational number. Okay. But if I write 0 by 3, this is a rational number, but not this. Okay. The only condition is this q should never be equals to 0. Okay.
Yes, ma'am.
Okay. So now Vega, can you tell me the definition of rational number?
Okay, like the fraction that represents p by q is called rational number, and q is not equal to 0.
Okay, good. Abdullah, can you tell me now?
Rational numbers are like fractions of a number, and the denominator cannot be zero.
Okay, yeah, the denominator should not be equal to 0. Okay. Ibrahim?
Yes.
Mm-hmm.
Rational number is a number written in the p by q form, where q is not is equal to 0.
Good. Manal, can you tell me now?
Rational is a number that can be represented in p by q form, but q cannot be 0.
Yes, very good. Good. So now if anybody will ask you, you are starting with the rational number chapter. So what is rational numbers? I think you people can tell. Right? Okay. Now remember one thing. There are so many numbers, right? Whole numbers, natural number, integer, all that. Right? So whole numbers are those numbers that start from 0. Everybody knows that. Natural numbers are those numbers that start from 1. Right? Integers include positive numbers, negative number as well as 0. Rational numbers are those numbers that can be represented in P upon Q form. Right? Now what you will write in your notes. Yeah, one more thing. Manal and I think Ibrahim also knows that. When I'm teaching you, you people will not write anything. You will just look at the screen. You will just look at me. Okay? But after that, I will give you 2 minutes to write it down. So no need to worry that, okay, ma'am is teaching and we are writing side by side. No, you don't have to do that. Okay. So I'll give you time and I'll wait for everyone to finish. It's not like, for example, Abdullah and Vega and Ibrahim said that, ma'am, we are done and Manal is still doing. So you don't have to say yes if they said yes. No, you have to say yes when you are done. Okay. So don't feel like there is a peer pressure over here. You people are working individually here. So if something I'm teaching you, you are not getting it, others are saying yes, you are not getting it, you will take a stand for yourself and you will say, no, ma'am, we are not getting it. Okay? Clear? Fine? With everybody?
Yes, ma'am.
Yes, ma'am.
First of all, what you will write rational numbers. A number is called rational if it is expressed or written in P upon Q form. P and Q are integers, right? It includes natural, whole and integers as well. Okay, so we will quickly write down this. So for example, if I wrote this 1 is a natural number. So is 1 is a rational number as well?
No, ma'am.
Tell me. For example, 3. 3 is a whole number as well. 3 is an integer as well. And 3 is a natural number as well. So is this a rational number as well?
No, ma'am.
Yes,
No?
ma'am.
Mix. Voice. Abdullah, what do you say? Is this a rational number? This 3?
Ma'am, can you repeat the
Yes.
question?
Other question is this 3. This 3 is an integer as well, right? This 3 is a whole number as well. And this 3 is a natural number as well. But is this 3 a rational number as well?
Yes, ma'am, because it can be written 3 by 1.
Yes. So the answer is yes, ma'am. Any number which is an integer, which is a whole number, and which is a natural number, it will always be equals to a rational number. Okay?
What about 0,
Because,
Yes, ma'am.
sorry?
0? It is not right.
Yes, 0 is also a rational number. I told you, na, 0 upon 1 you can write. But not 1 upon 0. Clear?
Yes, ma'am.
Okay. So 3 can also be written like this. Or 3. Both are the same, right? Yes or no? 3 upon 1 or 3. Both are the same thing, Manal?
Yes, ma'am.
Yes. So that's why a number which is an integer or whole number or natural number, they are also the rational number because they can be written like this as well. 24. Just by looking, you will say, ma'am, rational numbers are represented in P upon Q form. This is also a number because you can write 24 upon 1. Same thing. Fine? Yes?
Yes, ma'am.
Yes or no, students? Clear?
Yes, ma'am. Clear, ma'am.
Okay. So now you will quickly write down this first. Okay. This we will make a note side by side. Rational numbers, a number that will represent till here. Okay. Then we will start with the properties of rational number. Fine.
Yes, ma'am.
Hello, madam.
Hello. Ayan, do you have a class with me?
Yes.
You have which class?
Fifth class.
Sorry?
I'm in fifth grade.
Fifth grade. So, Ayan, I don't think you have a class with me. Have we had a class, Ayan? Right?
Yes.
But today I don't think you have a class with me. Do you have?
Yes.
Let me just ask your counselor because right now I'm taking the class of 8th grade.
Okay. I'll see again.
Just ask your counselor that the link they shared. Do you have maths class or science class?
I don't know.
Oh. Then ask your counselor. Leave the meeting, ask your counselor and let me know. Okay?
It's written in the link that I have mathematics.
Maths with Sanya Bora?
Let me see.
They've mentioned the teacher name as well.
No, it's Soyhan Kyan.
Yeah, that's a science class then.
Okay, bye.
So I'll start teach science. Okay.
Okay.
You got the same link. Okay, let's.
Done, ma'am.
Ma'am, do we have to draw the figure?
Sorry.
Do we have to draw the figure?
Manal, you are not audible properly. Be loud.
Ma'am, do you have to draw the figure?
No need to draw the figure. That's it till here.
Okay, ma'am.
Okay, everybody is done. Boys done. Abdullah.
Ma'am, I'm done.
Okay, do it. Okay, everybody finished? No? Abdullah, I think others are done, na?
Ma'am, I'm
Vega
done.
is done.
Ma'am, I'm done.
Okay. Manal,
Yes, ma'am.
done. Okay, Abdullah, now you are done.
Yes, ma'am.
Okay, very good. Okay. Now, students, we are going to discuss the properties. Okay. So, listen to it very carefully how you are going to make the notes and how you are going to learn that. Okay. So, over here, first of all, I'm talking about how you are going to make the notes. Okay. First, you will put the heading. Okay. Properties of Rn, which is rational. Then first, we will be discussing about the closure property. Right? This you will write closure property. You will write the definition of closure property. Then you will draw a table. The table look like this. Okay. Here uses operation. Okay. Who will tell me what does operation means? Tell me. Operation means what?
Like addition, subtraction, multiplication, division.
Yes. So operation doesn't mean that, teaching the doctor operation. Okay. You are the maths doctor. So that's why over here operations means addition, subtraction, multiplication, division. Okay. So over here you will write addition, subtraction, multiplication and division. And here in operation, closed or not. So this we will make a table like this. Fine.
Yes, ma'am.
Okay. Okay, so now let's just start. Students, listen to it very carefully. Okay. So the first property over here is like we are going to discuss it. Properties of rational number. Okay. So over here, first is the closure property. Okay. So the closure property says one thing. The closure property says, for example, if you are adding two apples. Yes. So what should you get? You should get grapes or apple.
Apple.
Others? You should get grapes or apple. If you add two apples, what you will get? Grapes or apple?
Apple.
Apple. Everybody, Ibrahim and Manal,
Yes, sir.
what you will get? Not yes.
Apple.
Apple, right? So that means if you are adding two rational number, the answer should be a rational number itself. If you are adding two integer, the answer should be an integer. If you are adding two whole numbers, the answer should be a whole number. Like that. Okay. So this is what closure property says. Closure property says this shows that the operation of any two same type of number is also the same type or not. Okay. So if you are adding two rational number, the answer should be a rational number itself. Okay. So let's just see. For example, if you are adding two rational numbers, the answer is always the same. So you will say, ma'am, this is applicable. Okay. In subtraction, if you add subtract two rational numbers, the answer is always a rational number. Yes, ma'am. Done. Okay. Like for example, 3 upon 1 minus 2 upon 1. Okay. So this is a rational number. This is also a rational number. Right? So 3 minus 2, it gave me 1 upon 1. This is also a rational number. So yes, ma'am, subtraction, it is applicable. Right? In multiplication also, it is applicable. But in division, it is not applicable. Clear?
Yes,
Okay?
ma'am.
Because if you divide any number with 0, you will not get the exact rational number, right? So, that's why, see, forget about everything, students. Closure property. Closure property said one thing. When you add operation means either you will multiply, subtract, add, divide, whatever you will do. This shows that the operation of any two same type of number gives you the same type or not. So we says, ma'am, when we add two rational numbers, we get the rational number. So that's why closure property is applicable when you add two rational numbers. Okay. But when you subtract two rational number, the closure property is also applicable. When you multiply two rational number, the closure property is also applicable. But ma'am, when you divide two rational number, the closure property is not applicable. Clear?
Yes, ma'am.
Okay, only
Yes.
Vega is getting. What about other students?
Yes, ma'am.
Okay, Manal and Ibrahim.
Yes, ma'am.
Ibrahim. Ibrahim.
Yes, ma'am.
Though you know everything, but still you have to respond yes or no. Okay.
Yes, sir.
And
Okay.
at the end, I'll ask you questions because this is your second class doing the same. Okay.
Okay.
Be prepared. Okay, sir. So now, first thing, what you are going to do? Properties of rational number. Then you will write one closure property. You will write it till here. Okay. Then we will make a table like this, which I told you. Operation, addition, subtraction, multiplication, division. Like the same table. Okay, but no need to do these two. Only I just need this first. Operation, addition, subtraction, multiplication, division. Close or not?
Yes,
Close.
the table.
Yes. No need to draw the entire table. Okay. Vega, you asked something?
No, ma'am.
Okay. Clear? I'm just making a table here again for your reference. You have to make it like this only. Okay. Here you will write operation, addition, subtraction, multiplication, division. Here closed or not. Okay. So here tick, 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 raw. Clear? If I'll ask you the question like this. When you add two rational numbers, is closure property applicable or not? Tell me, Manan. When you add two rational number, Manan, just look at the screen and answer. When you add two rational numbers, closure property is applicable or not?
Yes, ma'am.
Yes, it is applicable. Okay, Ibrahim. When you divide two rational number, is closure property applicable or not?
When we? Hello?
Yes. Ibrahim, you tell me. When we divide
Yeah.
two rational numbers, is closure property applicable?
No.
Yes. Okay. Vega, when you multiply two rational numbers, are you getting the same number, rational number?
Yes, ma'am.
Okay. Abdullah, when you subtract two rational number, is closure property applicable?
Yes.
Okay, very good. Okay, so now let us make the notes. Okay. So first, what you are going to do? Properties of rational number, closure property. Write it till here and then make a table. Okay. Make a table. I think you can see it. Operations, spellings, addition, subtraction, multiplication, division. Then once everybody is done, I'll scroll it down. You will write cross and from here. Okay. Anyone who has any doubt how to make the notes? If you have doubt, let me know. I'll explain again. Tell me. Anyone, any doubt?
No, ma'am.
No?
Ma'am, how do you do the table?
The table, see. First, write properties of rational number, then closure property and write the definition. Then, make a table like this. Operation, addition, subtraction, multiplication, division. Like this. I made this. And here write closed or not closed, the second one. And write this. Tick, 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 raw. No need to do these two. Got it? Fine.
Yes, ma'am.
Okay. So now everybody first write this and then I'll scroll it down to the table. Okay. Done, students?
I'm actually not yet done.
Okay.
Done, ma'am.
Done, ma'am.
Done, ma'am.
Okay, everybody is done. Should I move to the table?
Yes, ma'am.
Okay, now this is the table. Quickly do it.
Done, ma'am.
Okay, everybody is done. Anyone else still doing that?
Yes, ma'am.
Okay, quickly, quickly.
Ma'am, actually, can I ask something? Ma'am, for Sandas and Chakrik, actually, which lesson is going on?
A third chapter.
Oh, okay.
We're just about to finish the third chapter. I think one more class.
Okay, ma'am.
Okay, students done?
Yes, ma'am.
Okay. Everybody is done. Should I move to the next property?
Yes, ma'am.
Okay.
Yeah.
Okay. Now the next property is commutative property. Okay. Now let's just see. For example, 2 plus 1. Okay. It gives me 3. Or if I write 1 plus 2, it also gives me 3. Right? So even if I change the position of the number, my answer is being affected?
No, ma'am.
No. right? So this is what commutative property says, that the position of number doesn't matter, right? If you swap the position of the number, then also the result would be same. Clear? So you will write the second commutative property and write till here. Then the table will do later on. Okay?
Okay.
Ma'am, excuse me.
Yes.
Till when is this class?
No, we have other one, but we don't have time, so we'll just do for today till here.
No, because over here it is time for prayer.
Okay, just write this down and then I'll ask you people to leave. Okay?
Done, ma'am.